All right, welcome to The Explainer. Today, we're talking about something pretty wild. A technology that's quietly building a mirror image of our world. I'm talking piece by piece, from jet engines all the way up to entire cities. It's called the digital twin. And we're about to dive in and see just how this whole mirror world thing actually works.
Just think about that for a second. Not just a 3D model, not some kind of plausible simulation. No, this is a living, breathing, dynamic copy of a specific physical thing, and it's connected to it in real time. Imagine a copy so perfect that it feels what the real object feels, right at the exact moment it's happening.
So why on earth would we want to do that? Well, the goal here is to be able to test, predict, and ultimately perfect our future. The promise is it's nothing short of revolutionary, really. You get the ability to run endless what-if scenarios to kind of see the future before it even happens. And maybe the best part? You can make all your mistakes in a world where they cost absolutely nothing.
Okay, so what makes a twin? What are we really talking about here? Let's break down what separates a true digital twin from, the other digital models we're all familiar with. We're going to go from a static blueprint to a living mirror.
The guy who basically came up with this whole concept, Michael Greaves, he put it really simply. He said, if you have enough data, you can model a DT and then move from real to digital. It all boils down to that one core idea. It all starts with data. If you can capture enough info about a physical thing, you can build its digital counterpart. Simple as that.
So here's the key phrase right there: bidirectional flow of data. Think of it like a two-way street. Data flows from the physical object sensors to the twin, telling it what's going on. But just as importantly, insights and even commands can flow back from the twin to change the physical object. It's not just a reflection, it's a constant, living conversation.
And this really gets to the core of it. This is the biggest point of confusion for a lot of people. You see, a 3D model or a VR simulation, that's a representation of a thing, like a car. But a digital twin, that's a living replica of a specific thing. It's not just a car, it's your car, with your serial number, its own unique history, its exact mileage, and hey, even the current pressure in its tires. That's the secret sauce, the live data link. The twin is tied to one unique physical thing, and it changes and evolves right along with it.
So how does this actually work? What's the tech that breathes life into these twins? Well, think of it like a living body. You've got the Internet of Things, or IoT. Those are all the sensors acting like a nervous system, constantly feeling and gathering data. Then you've got pervasive connectivity, like 5G, which is the high-speed circulatory system, pumping all that data around. And then you have the brain, AI and machine learning. They're doing the thinking, analyzing all that data, and making predictions, all powered by the massive muscle of cloud and edge computing.
All right, now let's talk about the different types, because it's important to know that not all twins are created equal. They actually evolve, moving from a blueprint to a specific instance.
It really happens in three main stages. First up, you have the prototype. This is the perfect virtual blueprint, right? It's used to design and test a product in the virtual world before a single physical atom is even touched. Then, once that product is actually built and out in the wild, it gets an instance. This is a twin of one specific, real thing. It's linked to an asset with a unique serial number, and it reflects its exact real-world state. And finally, you have the aggregate. This is the fleet view. It's a composite twin that pulls in data from many instances. Think an entire fleet of jet engines, so you can understand and optimize the whole system.
So why does this matter? Why go through all these stages? Because it means we can make mistakes where they're free, in the virtual world. The power here is just immense. You can design, test, manufacture, and heck, even break a product 1,000 times over in the virtual space. So by the time you actually go to build the real thing, you've already ironed out all the kinks. You've achieved a kind of virtual perfection.
Okay, this all sounds amazing in theory, right? But is this stuff actually being used? Let's look at some twins in the real world and see how this mirror world is already reshaping our reality. This next quote really shows you the sheer ambition we're talking about here. Just like we created the virtual twin of the Boeing 777, we are now creating the virtual twin of the human body. I mean, just let that sink in. The exact same principles used to digitally build one of the most complex machines on Earth are now being applied to the most complex system we know of, the human body.
And this is not science fiction, this is happening right now. Take a look at this number, 99%. That is the alignment rate between virtual surgical planning on a newborn's heart twin and the actual operation. At Boston Children's Hospital, surgeons can create a precise digital twin of a baby's malformed heart. Then, they can perform the surgery over and over again, virtually, testing every possible approach on that digital twin until they find the absolute best one. The result is a 99% match between the virtual plan and the real life-saving surgery. It's just incredible.
And honestly, the applications are just exploding everywhere. We're seeing a whole world of twins pop up. We're talking about rebuilding Notre Dame, but with integrated sensors to protect it. We're talking about Las Vegas casinos optimizing tables to spot cheaters. Porsche is designing entire EV factories in record time, all in the virtual world. Companies are simulating autonomous vehicle tests to save billions of dollars, and it scales up. We're managing entire smart cities like Singapore and even stress testing global supply chains against things like pandemics.
And as you can probably guess, when there's this much innovation, the money follows. Let's look at the size of the prize. The digital twin market itself is projected to be huge, around $78 billion by 2027. But look at the other bars. The real story here is that the digital twin is the gateway. It's the critical bridge that connects the physical world of IoT, a $1.4 times trillion market, to the burgeoning digital economies of the metaverse. We're talking about a massive, multi-trillion-dollar transformation, and digital twins are right in the middle of it.
But, okay, let's pump the brakes for a second. As with any powerful new tech, it's not all sunshine and rainbows. We need to talk about the risks and the hype and ground this incredible vision back in reality. And look, the hurdles to overcome are very real. First off, it's highly complex. Just deciding what parts of reality are even important enough to model is a huge challenge. Then there's the significant cost and time. We're talking years and major investment. And of course, there are huge questions around data security and privacy. I mean, who owns the twin and all its data? But you know, maybe the biggest barrier isn't technical at all. It's human. There's a big shortage of experts, and getting an entire organization to change its processes and its mindset, that takes way more than just new software. It takes real perseverance.
But even with all those hurdles, the momentum here is just undeniable. So let's look past the challenges and peer into the future. Let's talk about the ultimate vision, a twin of the entire world.
Yeah, you heard that right. The ultimate goal here is a complete live twin of the entire world. A single, unified, dynamic digital twin of planet Earth. Imagine a model that doesn't just understand one jet engine or one factory, but the incredibly complex dance between all of them. Our infrastructure, our economies, our climate, our societies. All of it mirrored in real time.
And if that wasn't enough, here's where things get really mind-bending. The prediction is that these intelligent digital twins will eventually self-modify and evolve completely independent of human intervention. They'll become so complex, so intelligent that they'll start to learn and adapt all on their own. They'll show us things about our world that we never could have seen ourselves, leading to outcomes that are totally unexpected and incredibly significant.
Which, of course, leaves us with one final, fascinating question to ponder. As we build this mirror world, what will we discover about ourselves? As we get closer and closer to creating this perfect digital reflection of our reality, what will it show us? What truths about our systems, our planet, and yeah, ultimately ourselves are we going to be forced to confront when we can finally see everything with perfect clarity?